All right, so number 5 out of your textbook. I'm going to read it from your textbook, but I'm going to like draw the picture and label some things. So I'm not going to write out word for word. You can read that out of your book, okay? So number 5, let me read it first. It says, a 0.15 kilogram baseball traveling at a horizontal speed of 4.5 meters per second is hit by a bat, and then it moves with a speed of 34.7 meters per second in the opposite direction. What is the change in momentum of the ball? Okay, so now let's reread it. I'm going to draw a picture. So there's a kind of a process for doing physics homework. First thing you do is you read it, and then after you read it, you kind of draw a picture. Okay? Step 2 would be to list what you know. Step 3 would be to list what you need to know. Right? Step 4 usually involves finding some sort of equation, and then step 5 is where you solve what you need to know. And then that's usually the question that they're asking you. Okay? So I read it, and it says, and I'll read it again one more time, a 0.15 kilogram baseball is traveling with a horizontal speed. So I have a baseball, and it is traveling with a horizontal speed. Now the mass of this baseball is 0.015 kilograms. Now why did I draw that 0 there? Does anybody know? It has to do with significant figures and precision. All right? So keep that in mind because we'll come back to that. And it is traveling with a horizontal speed or a velocity of 4.5 meters per second. Okay? And then it hits a bat. And when it hits the bat, once it hits the bat, then it moves in another direction at 34.7 meters per second. And it wants to know what the change in momentum is. So we've drawn our picture. Boom. We've listed what we know. Now this is technically what? What is kilograms? That's the mass. That's the mass of the baseball, right? Put that away. Courtesy. Yes, thank you. All right, good. All right, so now if I've listed what I know, right? Now when we read the textbook, what is it asking us? What do we need to know? What is the question that the textbook is asking us? What is the change in momentum? So now that I've listed what I need to know, what's the next step? Equation. At this point, there's probably some sort of equation that links velocity and mass. Now, I've shown you a lot of equations since the beginning of the year. But what I want you guys to do is open your textbooks, and if you have it with you, and turn to page 212. And we know that, so let me list the main equation. We know that momentum is equal to mass times the velocity. Okay, we know that. And we have a change in momentum. Well, technically we have a change in momentum because we have a change in velocity. So now, if you turn to page 212 in your textbook, if we say change in momentum, didn't we just talk about change in momentum yesterday? Didn't we give that a name? What did we say the change in momentum was yesterday? Impulse. It was impulse. And so if you look on page 212, there's a formula for impulse, right? Can somebody tell me what that formula is?
Impulse is
Yeah, it's the change in momentum. So one way we could calculate the impulse is that we could take the force, right? And the average force times time, right, or the change in time, that's one equation. This is how we get, which is the change in momentum, which is technically what we're looking for. And then it says the change in momentum of an object is the mass of the object times the velocity final minus the mass of the object times the initial velocity. Now, I know what I need to use. I'm not going to use every formula up there, but I'm doing this on purpose. I find something, I'm totally clueless. I don't know how to solve a problem, but I know I need to do something with change in momentum. And I look at my book and I remember that change in momentum is this delta P thing. And then I don't read the book because I'm in a hurry and I'm nervous and I'm anxious, but I see this formula here, and it says the change in momentum is all this stuff. So now what I need to do is I need to go back. What do I have? Well, I have the initial velocity, I have the final velocity, and I have the mass. So now if I go back and I look at my equation, what can I use? Well, I could use this, right? Does that make sense? All right. Now, if you just sat there and looked at it and was like, I don't remember how to do it, I don't know how to do it, well, you never will because you didn't discover what momentum is. So we got to get in this habit of following this process. We're going to draw the picture, list what we know, list what we need to know, and then find some sort of equation. Then when we're done, we're going to take that equation and we're going to solve. So I'm going to say that delta P, which is the change in momentum, is equal to the mass. Now I'm going to write it a little differently because the mass doesn't change, right? So couldn't I, if I factored out the m, couldn't I write it that way? It doesn't matter. You'll get the same answer. This one's just like one step less. So what was the mass of the ball? 0.15. What was the final velocity? 34.7 minus the initial velocity, which was 4.5. Now, some of you, I heard some few comments as I wrote that down. Now, I might be making a mistake. I might not be making a mistake. I don't know yet. Isn't velocity a vector? All right, so if velocity is a vector, in other words, this velocity is a vector, and this velocity is a vector, what should those two numbers have or say, or what is Mr. Adams not quite written down yet?
Signs.
The signs. Which one do we want to make positive? It could go either way, but which one would make sense to you guys?
4.5.
Yeah, so if I make this one positive, what does this one need to be? Negative. Now, if that's the case, I've got to come down here and make this negative, right? Is that right? Okay, so now if I make that one negative, then I have to subtract the positive. Hold on 1 second. Hello, this is Mr. Adams. Yeah. Sure. Bye. Katie, you guys go to the office. Yes.
Okay, actually now thinking about it, if the baseball is coming towards you, it's going backwards and then you're hitting it forwards. So maybe the 4.5 should be the negative one, and then you add the opposite and it's adding it.
So she's thinking of like our motion sensor, right? Like if it's coming towards you, it's negative. And if it's, truthfully, it won't make that much of a difference, okay? So what she's saying is like let's make this negative and let's make this positive, right? Now if we come down here and we do that, then this has to be positive. And then when we minus a minus, it becomes a plus. Now the answer will still be the same no matter what, It's just that the number value will be the same, but the plus or minus will be different, right? This will yield a positive answer. We're getting the exact same answer we would have gotten before, except it would have been a negative answer. And that makes sense because the change in momentum, the momentum is the vector in which it's the change, how much did we change. And so we'll talk about that in a second, but numerically it doesn't change the magnitude of the vector. Does that make sense? But it's perfectly okay to do it her way. That's why I switched it, just so you guys can see that mathematically it works out the same. You're going to have to think in terms of plus and minus as being this direction or that direction, right? And then mathematically you got to think of it like positive or negative too. So now what is this on your calculators, guys? Let's do this on our calculator. What is that on the calculator? So if I say 34.7 plus 4.5, I get this number. 39.2 times 0.15, I get 5.88. Right? Now, if I would have left it the other way around, I'd have negative 5.88. Okay. So I get 5.88. Now, the unit of measure for change in momentum or impulse is kilogram meters per second. And I knew that when I listed all that stuff, and I should probably make note of this, our units match up because this was in kilograms and this was meters per second. So we didn't have to convert anything. Technically, that's the answer in the back of the book. Okay. Now, if you orientated it the other way, you may have gotten negative 5.88, which actually is the way the book did it, and it's negative 5.88. And both answers are correct because we could arbitrarily choose which direction is positive. See, by doing it this way, what we were saying is any motion going to the right is negative, any motion going to the left is positive. And I really like how she explained that. She said the ball is coming towards you. So the displacement or distance from you and the ball is getting smaller or decreasing, so let's just call it negative. And it's perfectly okay to do it that way. Either way, you get the same answer. So the change in momentum, though, was, if we think of it that way, it was moving in the positive direction when we were done, based on the way that we orientated it. Does that make sense? Any questions?